We continue in section 1 by looking at equations that have two variables, x and y, as two-part solutions. Now, we write the two-part solutions as ordered pairs, and since most equations in two variables have infinitely many solutions, it's hard to list the solution set by listing ordered pairs. So what we typically do is we graph these ordered pairs in the Cartesian plane, or the coordinate axes. The set, this is going to sound kind of silly and obvious, but the set of all solutions to an equation in two variables is a solution set. So when we see an equation, a lot of times we say the equation represents the solution set, or that the answers to the solution set are the ordered pairs. So what we're going to do is we're going to graph all these ordered pairs to this equation in two variables. We get the graph of the equation. Now, the graph represents the solution set because the solution set are the ordered pairs that correspond to the points on the graph. So a lot of times a person will see an equation like the example that I have up there, x squared plus y equals 4, and they'll say that that's a graph. Well, the solutions are actually the graph that we're going to create here, and we're going to use a t-chart. When we have an equation that we're unfamiliar with, you're probably better off creating a t-chart, looking for a pattern. Now, most of the stuff that we're going to start with in this first chapter, linear equations in two variables, of course we're going to get lines. The example that I have up here, that's the equation of a parabola. We're going to study that in more detail. But we're going to do this problem, even if you know how to graph this one from your previous math days. We're going to go ahead and do this one by creating a t-chart and graphing the points and looking for a pattern. Now I have the axes drawn out, and I wrote up here, set the scale for both axes. I have noticed that students have a tendency not to tell what each one of the tick marks here on the x-axis and each one here of the tick marks on the y-axis are. They just assume that if there's nothing written down that they're ones, but you always want to set the scale. So I put a 1 here and I put a 1 here. Sometimes I'll have a 2 here, or a 5, depending on the graph. So always set the scale even though it's obvious. You don't have to put down all the rest of the numbers, we can count, but you have to tell me what the first mark is on each axis, what they represent. I'm going to create a t-chart, but before I do, I'm going to isolate the y. I'm going to subtract x squared from both sides. And I have y is equal to 4 minus x squared. I find this is a little bit simpler if I can isolate one of the variables when I create the t-chart. You can see why it's called a t-chart. I'm going to plot a few points here. I wouldn't start with points like -10 or +15. I would pick stuff around 0. So maybe just for convenience sake, I'll plug in, I don't know, how about -3, -2, -1, 0, 1, 2, and 3. That should be plenty to get a pattern here. Now when I say plug in, we're substituting it into this equation here. Now I'm not going to do this every time because I didn't leave myself a lot of space here, but I'm going to plug -3 in for x, and I'm going to find the y that goes with it. So this is 4 minus 9, this is -5. Then I'm going to plug -2 in, and I'm going to go through this step one more time here. 4 minus -2 squared, so that's going to be 4 minus 4, which is 0. I'm going to plug -1 in. I'm going to get a 3. I'm going to plug 0 in. Do the arithmetic, I'm going to get a 4. I'm going to plug 1 in. I'm going to get a 3. I'm going to plug 2 in. 2 squared is 4. 4 minus 4 is 0. I'm going to plug 3 in. 4 minus 3 squared, 4 minus 9 is -5. Now that gives me 1, 2, 3, 4, 5, 6, 7 points. That should be hopefully enough to determine a pattern here. Now, I'm going to plot the points over here. -3, -5. Do the best I can. This is why when you do these assignments that you're going to have from this section and from the other sections that involve graphs, I would like for you to use graph paper or a ruler or both, because when you freehand it, it gets messy. Now I freehanded the tick marks, and they're not terrible, but if you were to look closely, if you were to get a ruler out, you would see they're not exactly uniform. They're just in the ballpark. So be very specific and very neat and careful with your graphs. -2, 0, that's right here. -1, 3 is right about here. 0, 4, right here. 1, 3 is right about here. Looks like I have some symmetry working. 2, 0. and 3, -5 to be down there. And I have kind of an upside down U shape here, parabola. I'm going to do my best to sketch this as neatly as I can. I'm going to put the little arrow on the end, that's fine. It's going to continue going downward. Try to be neat. It's a little tougher when you're doing the whiteboard, but there it goes, that's not terrible. I do want to point out 3 very important points. And those points are here, here, and here. This point is 2, 0, 0, 4, and -2, 0. Alright, these 2 points here and here are where my graph crosses the x-axis, and they're called the x-intercepts. And this is where my graph crosses the y-axis, and it's called the y-intercept. Those are good points to have because they're very easy to find. To find x-intercepts, you plug 0 in for y, and you solve for x. To find the y-intercept, you plug 0 in for x, and you solve for y. The intercepts are good points to have, and we'll talk about that in more detail in just a minute.